In the last lesson, we reviewed some of the basic skills of dividing, with a focus on integers. Today, we will look at some basic properties of division and some useful ideas to simplify division. Next, we will look at dividing fractions, and then we will wrap up our review of the four main operations of arithmetic with a lesson on dividing decimals. So let's get started. A major rule when we're talking about division is that you cannot divide by 0. Thou shalt not divide by 0. Well, what does division by 0 mean? Well, in this case, if we did 15 divided by 0, that means we would take these 15 dogs and we'd put them into 0 groups. How do we group something into 0 groups? Division by 0 is what we call undefined. So if we have something like 14 divided by 0, we would say that this is undefined. And if we have an expression that simplifies down, and when it simplifies down, there's a 0 in the denominator, again, this is undefined. Now let's look at this algebraic expression. Well, if x is equal to 3, we would have 14 all over 5 minus 3, and that's 14 all over 2, which is equal to 7. Nice integer. And for pretty much all values of x, we would end up with a real number. But there is a case where this is not true. How about where x is equal to 5? So we'd have 14 all over 5 minus 5. So once again, 14 over 0. And this is undefined. Oftentimes, where expressions or functions are undefined, strange things can happen. So it's important to be able to find where algebraic expressions and functions are undefined. Now let's look at division into 0. So in this case, we have 0 divided by 5. So 0 is in the numerator and not in the denominator. Well, if I have 0 dogs, I may want to put them into 5 groups. But if I don't have any dogs, each of those groups are going to end up with nothing. So division into 0 is 0. So let's practice a few of these. So 0 divided by 14, well, that's 0. 5 minus 5 over 14, so that's 0 over 14. And so therefore that's 0 as well. In this last example, if x is equal to 5, we'd have 5 minus 5 all over 14. This is 0 over 14, and this is 0. Now let's look at self-division. In this case, the numerator and the denominator are the same number. So 5 divided by 5, I have 5 dogs. I want to put those dogs into 5 groups, so each group will end up with 1. X divided by x is equal to 1. So 14 divided by 14, that's 1. If we have some math beforehand, we have 14. 19 minus 5 is 14. So that's equal to 1. And when x is equal to 5, we have 14 all over 19 minus 5. That's 14 over 14. And that's equal to 1. Now we have looked at 3 scenarios, 3 different situations. We looked at when the denominator is 0, and x divided by 0 is undefined. We looked at when the numerator is 0, so 0 divided by x, and that's 0. And then we looked at when the numerator and the denominator were the same number, or self-division, and that is 1. Notice in these last 2 cases, we led off with if x was not equal to 0. Well, what happens when x is equal to 0? Now we have both the numerator and the denominator equal to 0. Well, if division by 0 is undefined, then 0 divided by 0 should also be undefined. But if 0 is in the numerator, well then it's 0. But we also have the same numerator and denominator, and that's 1. So which one of these three options is true? One way to look at this is to see what happens as we get closer and closer to 0 without actually reaching it. So instead of 0 divided by 0, let's pretend like we have 0.1 divided by 0.1. Well, that's equal to 1. How about 0.0001 divided by 0.0001? Well, that's also equal to 1. So that makes you think, well, maybe 0 divided by 0 is 1. Now, we already said that x divided by 0 is undefined, and there's no conditions here. For all values of x, if you divide by 0, it's going to be undefined. So now let's look more at this one. What's happening when x gets closer and closer to 0 here? So now we have 0 divided by 0.1. Well, that's 0. Let's try getting even closer. We have 0.0001. That's 0. So both of these arguments are valid, and we're coming up with two different answers, 1 and 0. So therefore, mathematically, this is considered undefined. So 0 divided by 0 is undefined. Now we have division by 1. So we have 1 in the denominator. So if I have 5 dogs and I want to put them into one group, well, there's going to be 5 dogs in that group. So x divided by 1 is equal to x. So 5 divided by 1 is 5. We do this math, we get 5 all over 1, and that's equal to 5. And then at x equal to 4, we have 5 all over 5 minus 4. That's equal to 5 over 1, and that's equal to 5. So in one of our very early lessons, and we were looking at integers or whole numbers, we made this a rational number, a ratio of two integers, by writing it as 5 over 1. We also did this when we were practicing multiplying fractions. And we'll see something similar when we practice dividing fractions in the next lesson. Division is not commutative. The order matters. So a divided by b is not equal to b divided by a. So an example here, if we have 4 divided by 2, well, that's 2. 2 divided by 4, well, that's 2 over 4. And then that simplifies down to 1/2, and those two are not equal. Division is not commutative. The order matters. Division is also not associative. The way that the numbers are grouped also matters. So using a little bit of PEMDAS here, order of operations, we do everything in parentheses first. So 8 divided by 4, that's 2, leaving us with 2 divided by 2, and that's 1. Now on this side, again, we're going to do the items in parentheses first. So 8 is going to be carried down. 4 divided by 2, that's 2. Then 8 divided by 2 is 4. So these are not equal. The way that the numbers are grouped matters. So both addition and multiplication are commutative and associative. you can change the order and you can change the grouping when you're adding and multiplying. This is not true with subtraction and division. For both of these operations, the order matters and how they are grouped matters. Looking at closure, a set of numbers is closed or has closure under a given operation if the result of performing that operation on any two elements of the set results in an element of that set. So which of these sets are not closed under division? And providing a counterexample. But we talked a lot about 0, and division by 0 is undefined. So any set that has the number 0 will not be closed under division because division by 0 is undefined. So if we look at these whole numbers, 5 divided by 0, that's going to be a good counterexample. So if we look at an integer, we can say negative 5 over 0. That's also undefined. And a rational number, we could have, we'll talk about complex fractions in the next lesson, but we could have something like 1/2 all divided by 0. Again, division by 0 is undefined. So all three of these are not closed. Well, how about natural numbers? Natural numbers do not contain 0, or at least our definition of natural numbers. So we could have something like 6 divided by 3, and that's going to give 2, and that's fine. But if we reverse that, 3 divided by 6, that's 1/2. That's not a natural number, so this is also not closed. And then irrational numbers. When we look at irrational numbers, radical 2 divided by radical 5, square root of 2 divided by square root of 5, well, that's going to be another irrational number. But how about that self-division? So radical 2, square root of 2, divided by square root of 2. Well, that's equal to 1. And 1 is not irrational. So that also is not closed. It turns out the set of real numbers is not closed under division. Now here's a problem we can solve with order of operations. So we do parentheses first. So we do 6 times 8 times 7 times 5 to give us our divisor. And then we'd multiply 10 times 12 times 14 times 16 to get the dividend. And then ending up with the quotient. Let's see if we can do this in a better way. So the first step is converting that division to multiplication. So I will rewrite the dividend. And then the divisor becomes the reciprocal. I'll put the dividend over 1. So things all lined up. So numerator times numerator, denominator times denominator. So now we'll multiply. So now we have 10 times 12 times 14 times 16 in the numerator. All over 6 times 8 times 7 times 5 in the denominator. Next, I'm going to factor that numerator a bit. So 10 becomes 2 times 5. 12 is 2 times 6. 14 is 2 times 7. And 16 is 2 times 8. We'll leave the denominator as is. 6 times 8 times 7 times 5. Now we can cancel things out. So that 6 cancels out. The 8 cancels out. 7 and 5. And that leaves us with 2 times 2 times 2 times 2. 2 times 2 is 4. Times another 2 is 8. and then a fourth time is 16. So the answer to this complex problem is 16. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do this one problem. Again, we're going to use the definition and properties of division to simplify down this problem. First thing is we converted division into multiplication, so the divisor became the denominator. And then we start factoring both the numerator and the denominator, looking for common terms in both the numerator and the denominator that can be canceled out. So in this case, we had 113. If you notice, 226, well, that's double of 113, so that allows us to cancel that out. 16 is 2 times 8, so that gives us those 8s that can be canceled out. And then we have 2's. We have a couple sets of 2's that all get crossed out, leaving us with 15 over 10. We can factor that down further, leaving us with either 3 over 2, 3 halves, or we convert that to decimal 1.5. Continue practicing, working with the definition and properties of division, and I will see you in the next video.